Hello friends, in this video we will study about the operating modes of the 8257 DMA controller. In this video we will also study about the registers, status register, mode set register and the count register of the 8257. So let's start with our topic. We know that the DMA controller 8257, it has 4 channels, channel 0, channel 1, 2 and 3. And all these 4 channels, they are used to connect the input-output devices with the memory of the microprocessor or the central processing unit. This direct memory access controller, it is used to transfer large amount of data from the memory to the input output devices or from the input output devices to the memory. So we can say that if this is the CPU, or we can say it's memory, and it's the DMA controller 8257, and this is the input output device. So this input output device, it will be connected first to the DMA controller. It will transfer the data to the DMA controller, and then this data will be transferred to the memory of the CPU. Okay, and again, if this memory, it wants to if this input output device, it wants to read some data from the memory, large amount of data, then that data will be sent from the memory to the DMA and then from DMA to the input output device. So this DMA, it has 4 channels for this connection, and these channels are from channel 0, then channel 1 and channel 2 and channel 3. So these are the 4 channels which are used by the input output devices to transfer the data to the memory, or by the memory to transfer the data to the input output devices. Now there are 4 channels, so we can say that 4 input output devices can be connected, and those input output devices can transfer or receive the data from the memory. Now each channel of this 8257, it has 2 programmable 16-bit registers. So to each of the channel will have 2 programmable 16-bit register, which are known as the address register and count register. Because when this data is transferred by the between these memory and input output devices, so which input device is connected to the 8257, then that input output device will have some specific address, and this memory location where the data has to be stored, or from where the data has to be picked, that address is also to be known to the DMA. So for holding the address of the memory location, or for the input output device, we have the address register, And count register is used to count the number of bytes which are transferred by the DMA. Okay, because data is transferring, so data is in the form of bits, and one by one bit will be transferred, then the second bit will be transferred. So how many number of bits are transferred, that also we want to know. So the count register, it tells that this many number of bits are transferred by the DMA. So the address register, it is used to hold the address, and count register, it is used to hold the number that how many bits have been transferred. So first we will study about the address register. The address register, as I have told, that it is used to store the starting address of the memory location for the DMA data transfer. So the starting address of the memory location from where the data has to be picked, or from where the data has to be stored. So that starting address of the memory location, it is held by this address register. Now the address which is there in the address register, it is automatically incremented after every read, write, verify, transfer operation. Whenever transfer of data takes place, then there are three operations associated with it, which are the read, write and verify. Read means to read the data from the location, like from the memory or from the input output device. Write is to write that data to the destination location, that will be either the memory or the input output device. And verify means that the data which is transferred, it is correct and it has reached to its destination location. So every transfer will have these three things, either read, write or verify. And when for every bit which is transferred, if these three operations are done, then the address in the address register will be incremented, and the data which is at the next memory location, then that data will be transferred. So if we take, suppose here, this is the memory location having the stored the data which is to be transferred. So the starting address will be held by the address register, and the data bit, like suppose 0 is stored there, so 0 will be transferred to, suppose, an input output device. So this 0 will be first read from this memory location and then written at the input output device, and then it is verified that 0 is correctly transferred at the destination location. Then this address in the address register, it will be incremented, and the data at the next memory location, then that data will be transferred. So in this way, the address register, it is used to hold the address and then incremented to show that this data the DMA wants to transfer to the destination locations. Now next comes the count register. The count register, it is used to count the number of byte or word transferred by the DMA. So like 128 bytes of data the DMA wants to transfer. So for every byte which is transferred, the count register will hold that this much amount of data is being transferred by the DMA, so that the DMA get an idea that this much is transferred and this is the remaining amount which it has to transfer to the destination. Now the format of this count register is so this count register, it is a 16-bit register, so it will have the 16 bits. So starting from the LSB, we will have the bit number 0, and then we have the MSB as the bit number 50. So these are the 16 bits of the count register. Now in these 16 bits, we have the 14-bit count from the bit number 0 to bit number 13. This is a 14-bit count. And the bit number 15 and 14, they decide that which operation like read, write or verify transfer, it has to be performed on this 14-bit count. So if this is 0, 0, then the operation is verify transfer. Then if it is 0, 1, then it is write transfer. If it is 1, 0, then it is read transfer. And if it is 1, 1, then this is an illegal, means it is not allowed. So 0, 0, it is for verified transfer, and these bits, the 14 bits, they are the count value, and 2 bits, they indicate that the type of the DMA operation which is performed. So we have, this is the count register. The bits B0 to B13, it is the 14-bit count value. So the bits B0 and to B13, they are the 14-bit count value. B14 to B15, these 2 bits, these are used to indicate the type of DMA transfer, either read, write or verify. So in read transfer, the data is transferred from the memory to the input output device, and in write transfer, the data is transferred from the input output device to the memory. Now we have this verified transfer operation. So verification operations, they generate the DMA addresses without generating the DMA memory and input output control signals. So verification operations, they involved that to verify the data bit which is transferred by the DMA. So these are the three operations which are performed by the DMA, and that was the count, register, mode. Now, the address register and count register, these were the 16-bit registers. Instead, the 8257, the DMA controller, it also has 8-bit registers. Two 8-bit registers are there, which are the mode set register and the status register. So we have studied the 16-bit. Now let's come to the 8-bit registers. So these are the two 8-bit registers in the DMA, mode set register and status register. First we will study about the mode set register. Let us first see the format of this 8-bit register. It will have the 8 bits. The bit 7, it is the AL bit. B6 is TCS. B5 is EW. B4 is RP. This is EN3, EN2, EN1 and EN0. So this is the format of the 8-bit mode set register. Now the use of this mode set register are: first is to enable or disable a channel. Second is to fixed and rotating priority. So these are the uses of this mode set register. Now let's see the description of all these 4 bits. First we have this bit 7, which is AL. This, its full form is auto reloading. So it describes the 5th use of the mode set register, which is auto reloading of channel 2. Let's see, we have the bit 7 as AL, which is the auto reloading of channel 2. Now this bit, if it is 1, then it will enable the auto reload. And if it is 0, then it will disable the auto reload. So what does this auto reload means? When this bit is 1, then the contents of the channel number 3, count register and the status registers, they are loaded into the channel number 2. So when this bit 7, it is 1, it means enable the auto reload. So the contents of the channel 3 count and the address registers, they are loaded in the channel 2 count and address registers respectively. So the contents are copied from channel 3 to channel 2, and when this copy of the contents will take place whenever the channel 2 it reaches the terminal count. Terminal count means that the count value has reached to 0. So when the count has become 0 of this channel 2, then the contents of channel 3 count and address register, they are loaded in the channel 2 count and address registers. Now when this mode is activated, means this auto reload is activated, then channel 3 and channel 2, they are having the same contents. So the number of channels for the DMA, they are reduced from 4 to 3 because the contents of channel 3 and channel 2 are same. So the number of channels is reduced. Now let's come to the bit number 6. Bit number 6 was TCS, that is terminal count stop. Okay. So bit number 6, TCS means terminal count stop. Now when this bit is 1, it means stop the DMA controller on terminal count. This bit B6, which is the TCS, that is the terminal count stop, this bit is used to stop the operation of the DMA controller when the terminal count is reached. Terminal count means the count value has reached to 0. So this was bit number 6. Then we have bit number 5, which is EW. Now this bit is set to 1. So when this bit is set to 1, then the timing of the low write signals, which is the memory write and the input output write operations, they will be extended. So if B5 it is equal to 1, it means we have the extended write selection, and when it is 0, then it is normal write selection. So this was bit number 5. Then we have bit number 4. So bit number 4, it is RP, and this bit is used for rotating the priority of the 4 channels of the DMA. So when this bit B4 it is set to 1, then the channels will have rotating priority, and if it is 0, then the channels will have fixed priority. So what is the rotating and this fixed priority? Because when the 4 channels, because it is having the 4 channels, so we can have 4 input output devices connected to the DMA, and these 4 input output devices can transfer the data to the DMA. Now, if four are connected to DMA at the same time, then which input output device data will be first transferred? That will be decided by the priority of the input output devices or the priority of the channels. So in the rotating priority, the channels, they have their priorities are rotated time to time, whereas in the fixed priority mode, the priorities of the channel is fixed, and according to that priority, the data is transferred. So in the rotating priority, now, in rotating priority, after servicing a channel, its priority is made as lowest. Suppose all the four channels are connected and first channel 2 data is transferred. So after in this rotating priority, after this data of the channel 2 is transferred, then its priority is made at the lowest. Then suppose channel 3 is transferred, then its priority will be made lowest. Then if channel 4 is data is transferred, then its priority will be made as the lowest. So in this way, the priority has been decided in the rotating priority. Whereas in the fixed priority, the channel 0 has the highest priority and the channel 2, it has the lowest priority. So this bit before it is the RP, that is rotating priority, and this bit is deciding that the channels are, what is the priority of the channels and in which mode, either in the rotating priority mode or in the fixed priority mode they are working. Now let's come to the bit number 3, bit number 2 and bit number 0. So these three bits, they are used to enable the channel, the four channels of the DMA, which are the bit number 3, 2, 1 and 0. So bit number 3, it is EN3, means it is for channel number 3, and when this bit is 1, then it enables the channel, and when it is 0, then it will disable the channel. So this is for channel 3. Then we have bit number 2, bit number 1 and bit number 0. This is for channel 2, this is for channel 1 and this is for channel 0. Again, if it is 1, then it will enable the channel 2, and if it is 0, then it will disable the channel 2. If it is 1, then it is for enabling and disabling the channel number 1, and this is for enabling or disabling the channel number 0. So these 4 bits, these are the enable and disable bits for the 4 channels. So in this mode set register, we have studied all the 8 bits. This was an 8-bit register. AL is for the auto reloading of the channel 2. So it is the 5th use of this mode register. Then TCS is for the stop DMA on the terminal count. And EW, it is for extending the write signal operations. So we have the extended normal write time use. Then RP is for the rotating and the fixed priority. So it describes the second use of the mode set register. And these 4 bits, these are for the enabling and disabling the channel. So this mode set register, it has the 5 uses in it. Now next 8-bit register we have is the status register. So let's study the format of this status register. So these are the 8 bits of the status register. Bit number 7, 6 and 5, they are at the fixed logic 0, 0 and 0. Then bit number 4, it is for the reloading to state that whether the channel number 2 it is being reloaded or not. Then TC3, TC2, TC1 and TC0, these are for the terminal count for the 4 channels. So let us have, we have B0. If it is 1, it means that channel 0 has reached terminal count. Terminal count means that when the channels they are loaded with a count value, then they count value it is decremented or either incremented. So terminal count, it is the last value of the count which we want. So when this channel 0 has reached its terminal count, then this bit will be set to 1. Similarly for B1, if it is 1, it means channel 1 has reached the terminal count. Then if bit 2 is 1, then channel number 2, and if bit 3 is 1, then channel number 3. So these 4 bits, they indicates the terminal count status for the 4 channels, channel 0 to channel number 3. Now let's come to the bit number 4. Bit number 4 is for UP. So when this bit is 1, it indicates that channel 2 is reloaded from channel 3. So this bit indicates that whether the contents of the status and the count register of the status and count and address registers of the channel 3, they are copied into the channel number 2. So if it is reloaded, then this bit will be 1, otherwise it will be 0. Then bit 7, 6 and 5, these are for at the fixed logic. Also this bit number 4 of the status register, it is called UP, which is the update flag. Its full form is update flag. And the bits of this status register, they can be cleared out by the microprocessor. So the status bits of the status register, they are cleared out when after a read operation performed by the microprocessor. So we have studied the various registers of the 8257 DMA controller. First we studied the 16-bit register, the address register and the count register, and then we studied the 8-bit register, which are the mode set register and the status register. And these register, they decides the operational modes of the 8257, that in which mode the DMA controller it is working. Now the address of these status if of all these 16-bit and 8-bit registers, they are decided by, let's have a table for it. So the address for the channel 0 DMA address register, these are the address lines, 8 address lines are there. So when their value is 0, 1, 1, 1, 0 and 0, 0, 0, 0, then this channel will be selected. So the address comes out to be 60. Now for channel 0 count register, we have 0, 1, 1, 0 and this is 0, 0, 0, 1. So the address comes out to be 61. So this is channel 0 address and the count register. Then we have channel 1 address register and channel 1 count register. So for channel 1 we have again 0, 1, 1, 0 and this is 0, 1, 1, 0. This will be 0, 0, 1, 0, so it is 62 and this is 0, 0, 1, 1, it is 63. For channel 2 address register, again we have 0, 1, 1, 0 and here we have 0, 1, 0, 0. So it is 64. So this A7 to A4 lines, they have the fixed logic 0, 1, 1, 0 and the A3 to A0, these 4 bits, their values is changing. So the address of the all the registers for the channel 0 and channel up till channel 3, they are from 60 to 68. We have here the channel 2 address register. Then if we take channel 2 count register, so channel for 2, for all we will have 0, 1, 1, 0. This is also 0, 1, 1, 0. And this A3 to A0 will change. So here we will have for channel 2 count register, we will have 0, 1, 0, 1, then 0, 1, 1, 0. So the address comes out for the channel 2 count register. It is 65, 66, 67 and 68 for both the mode set and status register. So the address of the mode set register and status register, it comes out to be the same. So this mode set register will be used when we will have the write operation and status register is only for the read operation. So that will distinguish that which register is to be addressed. Okay. So these are the addresses of the various registers of the DMA controller. So in this video, we studied about the operational modes of 8257, which are decided by the registers of the DMA controller. First, we studied the 16-bit registers, the count register and the address register. And then we studied the 8-bit register, which are the mode set register and the status register. So this mode set register, it defines the different modes of operations of the DMA controller. So I hope that this topic is clear to you. Thank you.